welcome back to Everything in Swift. And let's solve the Leetcode problem. So Leetcode problem is a maximum total subarray value 1. I believe there will be 2 and this will be the hard question. So we are given in the array of nums lunch n with the integer k. So we have to choose exactly the k non-empty subarray. So we need to think careful. The k value given here is not the range of the subarray we can consider. So the subarray can be 1 to whatever the maximum of the array size we can choose. And then these or those subarray can be overlap each other, and we have to find the minimum and maximum from these subarray we able to generate that, and then we find the difference between the max and min of the subarray. And yeah, and then we have to find k times of minimum and maximum, and we have to return the possible of those values can be achieved. So let's go through the example 1. If we have to create the subarray, we can create like multiple approach. Like 1 alone here is a subarray, but this is a bad idea to draw in here. Let's draw something here. 1, 3, 2. So like in here, the 1 alone also can be subarray. How about 3 alone, 2 alone? So we got the 3 subarray. How about 1 and 3? So why don't we consider like single subarray like 1? So if we choose a 1 as a subarray, the minimum will be 1 and the maximum will be also 1. So 1 minus 1 is 0, which is not going to create any value to us, so we'll drop that option. So we start moving from the minimum option as 2. So 1 and 3, minimum is 1, maximum is 3. So we took the maximum, which is 3. How about we choose the same subarray again, like minimum is 1 and maximum is 3. So we take the minimum, which is 1. So 3 minus 1, which is 2. So that is one option. How about we choose like this? Minimum is 1 and maximum is 3. How about 3 and 2? Maximum is 3 and minimum is 2. So if we took that, the difference will be 1. So it doesn't help us. So we have to fully utilize the maximum values of each. So my consideration is, how about we take the maximum and minimum number from the array, and then we multiply with that value. So that could help. I think it's the same for the example 2. So we have the option like 0 to 3. 0 to 3, which is the whole array. We take the minimum as 1, maximum as 5. So 5 minus 1 is 4. The same again, we choose the same subarray. How about we choose the last one like 2 to 3? Alright, okay, let's try to experiment our option that we just set right now. That will be minimum of nums dot minimum max and nums dot max. Yes. But I believe these are going to return the option here for us. And what I want to do is min max minus min. I believe that is the option for us. Let's try to submit. Okay, I was expecting that if I have to think about the space and time complexity, the time complexity will be the O of n and space complexity will be the O of 1, because we don't use any extra memory. Yep. And then there is even also one better solution from Swift that is called min and max. Let's call like min and max, which is going to be the nums of min and max. Since it could be the option here, let's do like min and max. Okay, and let's return 0. We can simply do with the min and max dot min, should be the max, min and max dot max, should be the max and min multiplying by k. So actually this main and max is native API from Swift algorithm. I would say it's a package or library. Library is much better. If we are not allowed to use, we have to do the traditional like main and max. If not, we can just use the main and max. I just noticed that is available in Swift algorithm package today. If we check that, so that is available in the main max as since the 1.2.1. Not sure, maybe since the 0.01. Oh, I don't know. I'm just randomly guessing. Alright, I hope you guys enjoy my solution and see you in the next one. Bye.